from multiple choice topic 3. Number 50. Oh yes, I am glad you asked. Speed of the particle. Speed is increasing. Let's see. So speed is increasing. Do you remember the rule for this, or is this why you're asking? The speed is increasing if velocity and acceleration
are both the same sign.
If velocity and acceleration have the same sign. Right, that's kind of tricky. That's the whole, if your acceleration is negative and your velocity is negative, let's do the other one first. If your velocity is positive and your acceleration is positive, well then you're speeding up going forward. If you're in reverse, backing down your driveway, and you're speeding up, we'll phrase it this way, your acceleration is negative because you're getting more and more negative. So if the signs match for velocity and acceleration, then your speed is increasing. If the signs are fighting each other, then you're slowing down. So let's back up to, there's the position. So velocity is 4t cubed minus 18t squared plus 24t. The velocity is at rest. Well, I think I need to get all of the signs. I basically need to do the overlapping sign chart thing to see where velocity and acceleration match up. So if I factor out a 2t squared minus 9t plus 12. So surely that factors if this is a no calculator test. They would need to both be negative. Let's see, 6 and 2 wouldn't work. 3 and 4 work. Did I do this right? Maybe that's the next question. 4t cubed, 18t squared, 24t. Yes. Factor out a 2. 6 and 1. No, 12 and 1 wouldn't work. 6 and 2 wouldn't work. 3 wouldn't work. 4 wouldn't work. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I think this is actually good news though, because I'm looking at my answer choices for when the particle is at rest, and t equals 0 is definitely one of them. And if this thing doesn't factor, then it's not going to be 2 or 3. So I'm thinking this thing, I'm going to get a negative under this radical here. 81 minus, let's see, 8 times 12 is 96. Yeah, that's the square root of a negative number. So it was ugly, but ultimately that's good news because there's only one place where it's at rest. Which is great. That means it's always positive on one side or always negative on the other. So my velocity picture, like the only 0 is at 0. And if I plug in, let's plug in something really big. That way it'll be easy to check, because then the only thing that matters is the lead term. Or I can plug in 1, I guess. If I plug in 1, I get 28 minus 18 is 10, so it's positive over on this side. It's going to be negative on the other side because this was a single root, not a double root, so I know it will change. But if I want to plug in -1, I could do that. So there's my velocity sign chart, I guess is the way to say that. The velocity is increasing. Oh, that would be when acceleration is positive. I know you asked 50, but I'm just going to work all 3 here. So acceleration then is the derivative of velocity, 12t squared minus 36t plus 24. They were at least kind on that one. I mean, kind in terms of 12 will factor out. And it factors easily. So t equals 2 and t equals 1. So for my acceleration sign chart, if I plug in 0, I get positive 24. So I know its acceleration is positive everywhere left of 1. And if there were no repeating factors, I can do these kind of shortcut here. I know I'm going to be changing signs at each 0. So minus, 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 and then we get past 2, plus, plus, plus again. So velocity is increasing when acceleration is positive. That would be there it is, less than 1 or greater than 2. And then that last question is, where do they have the same sign? From 0 to 1 and from 2 over. They have the same sign. It doesn't have to be that they're both positive, as long as they're the same sign. So 0 to 1 and greater than 2. So the speed is increasing when v and a have the same sign.
So if they're both negative, it would still be increasing?
Correct. Yep. If they were both negative, they would also be increasing. They would be increasing negatively, but the speed, you'd be speeding up going backwards if they were both negative. Good question. Lots of good stuff in that problem, or set of problems. What else? 63. Okay, we started 63, but we can go ahead and finish 63. Mean value theorem means that calculus slope equals algebra slope. So the calculus slope, I'm going to rewrite this. Yesterday we had more time in some classes and they worked this problem, and some people rewrote it like this. Other people did it as a quotient rule problem. I'd rather avoid the quotient rule, but it worked. So f prime is positive 6x to the negative 2, or 6 over x squared. Right, bring the power down, decrease the power by 1. So there's my calculus slope. My algebra slope is going to take a little work because I need to find f of 1 and f of 6. I got my x values. 6 minus 1, but I need my y values. So f of 6, 7 minus 6 over 6. 7 minus 1 is 6. And then f of 1, 7 minus 6 is 1. So that worked out kind of nice. So calculus slope equals algebra slope. You also have plenty of room on the multiple choice part on the test. They're really spread out. So you get this full booklet you can write in. So you're not going to be squished for space. You don't even have to have scratch paper where you're going back and forth. Like, you'll have plenty of space on the actual test to write whatever you need to write. So x squared equals 6. So x equals plus or minus the square root of 6. I already have that thrown out. Why did I throw that one out? Because it's got to be on the interval, so I can't have a negative. And so if I throw out the negative one, I'm left with positive square root of 6. Mean value theorem. Calc slope equals algebra slope. and it happens somewhere on the interval. So make sure you're on the interval. In fact, that was the main differentiation between answer choices A and D, was whether it's on the interval or not. And I think the same thing happens in 64, because it says how many values in the interval satisfy the mean value theorem for the function on the interval. Like they don't ask what they are, but I guess you have to find them to figure out how many there are. Anything else? I think there's only one more that I was concerned with. 62? Are you okay with 62? Well, whether you are or not, I'm going to work 62. The function, that thing, has a horizontal tangent. Horizontal tangent, what's that mean? You can see it there. What's 0? Slope is 0, f prime is 0. So when I see horizontal tangent, I'm thinking f prime is 0. Point of inflection, what's that mean? F double prime changes signs. Okay, for the same value of x, what must the value of b? Alright, so first derivative, 4x cubed plus 2bx plus 8. And we want that to equal 0, but that's kind of tricky because there's a b and an x in there, so hold off on that for now. Second derivative, 12x squared plus 2b equals 0. Okay, well, I feel like this one's going to be a little bit easier to work with. In fact, 2b equals negative 12x squared. And I see there's a 2b in the first equation. So I'm going to replace, I guess I should solve for b, but I just conveniently see that there's a 2b, so I'll just solve for 2b and stick negative 12x squared in for 2b. And maybe this will tell me what x is. So 4x cubed minus 12x cubed plus 8 equals 0. So negative 8x cubed plus 8 equals 0. So if I move things around, x cubed has to equal 1, which means x equals 1. And I guess officially I'd have to verify that it changes signs at x equals 1. But when I look at my answer choices, oh, careful. This is why we reread the question. I almost boxed C. Why would that not be right? Right, what's the value of b? So x equals 1. Tempting, but that's not what we're looking for. We want to know what b is. Let's back up. 2b equals negative 12 times 1 squared. So b equals negative 6. Oof, they almost got me on that one. Which, that would have been very unfortunate to get all the calculus right and miss the problem because you didn't read carefully what it was asking. It's looking for b, not x. So a little bit of, well, actually a lot of calculus. Calculus concept, then take two derivatives, that's calculus, a little bit of algebra, and also reading the question correctly. So there's like 6 or 7 things in that problem, none of which are terribly hard, but all of which prevent a place to make a mistake. Okay, so again, this stuff is due on Monday. Monday, and then the video is due Sunday by 11:45. I guess we probably shouldn't peek ahead yet, but I'll tweak next week's due dates because next weekend is prom and picnic and all the other stuff, so I probably won't make stuff due Monday, but we'll worry about that next week. Let's not get too far ahead. This week, stuff is due Monday. The worksheet packet, which is hopefully almost done. I should have been more clear on this. It's fine if you didn't do it this time, but in the future, do free response on a separate sheet and staple it. Multiple choice, usually there's enough work to kind of scratch it out in the sidelines, and that's fine. So again, Monday, this packet is due, and the video is due. Question?
Can you do, sorry, it was on the FRQ, but can you do 2A?
Sure. So 2A on the FRQ question. I don't know. Let's see. The function f is differentiable on the closed interval, and f of negative 2 equals 7. This is the graph of f prime. Again, always be careful about what you're looking at. That's the derivative of f right there. And they're not trying to hide that from you. The graph of f prime, the derivative of f, consists of a semicircle and line segments. Find the values of f of negative 6. Okay, I have information about f prime, and I want to find f. So how do I get from f prime to f? What's that? I need to integral, or integrate, or antiderivative. Because if I antiderivative f prime, I'll get back to f. Now I need to fill in some details on that because I need a top and a bottom limit. So f of something minus f of something else. But big picture, the antiderivative of f prime would get me back to f. Now what should I use for x values if I want to find f of negative 6? I'm thinking I should definitely use negative 6. What else should I use? If I use 5, that's going to give me two things that I don't know. So this is a little bit misleading. It's like, oh, let's use negative 6 and 5. But let's use negative 2 because we know negative 2. So I'll go from negative 6 to negative 2, which means f of negative 2 minus f of negative 6. So how can I evaluate, how can I figure out what this integral is?
So that's going to be the area under the curve.
That's the area under the curve. Area under f from negative 2 to 6, or from negative 6 to negative 2. 1, 2, 3, 4 times 2. Half of that is 4, so that area is 4 equals f of negative 2 is 7 minus f of negative 6. So f of negative 6, move things around, is 7 minus 4. And then you do the same thing for f of 5. Are you good with that? Okay. Another good example of if you get stuck on A, well, you can still answer B because f increasing, that would mean where's f prime positive? So answer B is an easy one, should be an easy one. Absolute minimum, that's going to take a little work because you'll have to check some endpoints. Oh, but A and C kind of go together because check endpoints, but you've already found the endpoints in part A. And then the second derivative, that would be the slope of f prime at -5 and 3. And it doesn't work at 3, and it does work at -5. So A might be the hardest one on there. B, C, and D aren't too bad.